So I'll go ahead and start recording. I'm kind of looking forward to discussing these topics today because last year with my class I started off with C# data types, and C# is changing every year, and so I wanted to kind of bring some more modern theory and like what's the new stuff with data types in C#. And you can kind of see here, this is C#'s modern type system, or basically modern data types in C#. And a lot of this has to do with performance, writing more efficient code, right? Because you could get it done, get software written with older C# with less performant code. The new idea is that newer C# is supposed to be more performant, and to understand a little bit of why it might be performant, you have to understand, well, all your data is stored in RAM, right? You declare a new variable, that variable is stored in RAM. Then depending on the kind of variable that it is, there's really two data structures that it could be stored in. One on the left is called the stack. Depending on your type of variable, your variables might be stored in the stack, or they might be stored in the heap. The stack and the heap work differently. The stack, think of a stack of papers, okay? The last in is the first out. So if you put a new paper on top, like you add a paper to the stack, it can pull it from the top. So it's a last in, first out order. But the general idea behind the stack is that it's fast. That's the general idea behind the stack. And the stack works with value types. Okay, so hopefully from first year, you guys remember reference types versus value types. As you guys are refreshing yourself on C#, I covered that last year in my theory, but that is definitely one of the most basic. Like, you can have value data types, you can have reference data types. Value data types, as we'll get into, they pass by value. You make copies, and reference data types, they pass by what's referred to as passing by reference. And so these are garbage collected. A big difference is if you have a variable that's running in a method and then that method goes out of scope, the memory is automatically reclaimed. So what happens is your program essentially takes RAM from the operating system to run. And then when the memory is done being used, it needs to return that RAM to the operating system. And so if a method goes out of scope here, then that memory can go back to the operating system. That's why it's fast. Method goes in scope, method goes out of scope. RAM is utilized, RAM is returned. The heap is less efficient. The heap is for more complex data structures that are referred to as reference types. And there's this whole other kind of, I view it as like a little software program called the garbage collector. The garbage collector is a program that runs every so often in the .NET ecosystem, and it just kind of looks for available unreferenced data that's not being utilized anymore, and then it returns it to the operating system. But the point is that the stack returns it a lot faster. This garbage collector, you cannot trigger the garbage collector to run. The garbage collector runs when it wants to run, kind of like in the real world. It runs every Tuesday, You cannot tell the garbage collector to run. So you cannot clean up your resources manually, whereas the stack, those resources get cleaned up a lot more efficiently. The point is, both of them are automatic. Both the stack and the heap, the data is kind of automatically managed for you. One just happens to be managed a lot faster than the other. Okay, so the question kind of becomes, well, why don't we just start putting more things on the stack? If the stack is kind of faster, why don't we just kind of put more stuff on the stack? And that's part of this lecture. Part of this lecture is, hey, there's some new things out there that instead of putting things on the heap, instead of putting our data on the heap, now there's some data structures out there where we can actually put more stuff on the stack. More of our data can be put on the stack and be more efficient. So that's kind of cool. When it comes to what data actually goes on the stack and what goes on the heap, value types, these are our, you often hear them called primitive data types. Integers, doubles, bools, okay? And then this new thing called struct. Okay, I'm going to come into struct here in a little bit. You probably haven't seen struct in the past. Nod your head if you agree with me. You haven't really seen struct, at least in that last C# class. Okay, you guys agree with me. You haven't seen struct. So struct is newer. Okay, at least you haven't covered it yet. Okay, but anytime you have a value type, like look at this little code chunk. We got A is equal to 10, and then we say B is equal to A. Essentially, you're making a copy of the data. You're setting B equal to 10, and now A is 10, B is 10, and they're separate variables. And so they're separate copies. And so by changing B, you do not change A. They are separate variables. Okay, and that's kind of how you would expect that to work, right? Value types kind of work as you might expect. Reference types don't work that way. By the way, what are reference types? The easiest way to think of reference types are your objects. Objects are your reference types, and arrays are objects, or arrays are also reference types. But here, classes and objects are essentially saying the same thing. Strings are objects and delegates as well. I know you haven't really seen this delegate, but regardless, this kind of has the way reference types work is you have two variables, essentially aliases for one another, and they point at the same data, right? So you have two variables that are aliases for one another. Therefore, changing one of the objects changes both of the objects. Okay. By the way, if this is foreign to you, if you're not familiar with value versus reference types, interviews I'm sure have changed. What interviews are like over the years nowadays, but this is one of those foundational things that is often an interview question. Can you explain value types versus reference types? Again, value types work on the stack, reference types work on the heap, and the way that they work with data is fundamentally different. So you can kind of see here, I've got this application object. I set the number of threads to 10. I have the second application object, and I change the number of threads on app 2 to 40. However, it is no longer 10. Both of those objects have the value of 40 there. So the number of threads on both of them is equal to 40 because they're a pointer at the same data. And so that's you could see the actual data there. The application object exists on the heap. All right. So those are just kind of some memory management things. Yeah, please.
That happens because we're not making a new application object. We're just copying the application.
Yeah, you're updating the pointer. You are making that is true. You're not actually saying a new application. In that case, those would be two different ones. Like if you had the keyword new application right here, then those would be separate objects.
I see.
Yeah.
I was just making sure.
Yeah. Yeah, so you can see here, if you were to output app 1 number of threads, it would output 40. Right? Even though we only changed the number of threads on app 2. So value types kind of work how you would assume they work, but reference types don't. Right? Okay. So this concept, there's a few concepts in here that you have to have some um, prior knowledge with C sharp. Okay. Now, integer value 123. Okay, we'll start with this line right here. Obviously, int is a primitive data type. But the way that C sharp works is that all of the value types, including integers, all the value types, including integers, can be treated as objects. Like you can have value dot to string. Well, that dot to string is available because value is an object. It can be treated as an object. Other languages, that's not the case. Okay, so here's a fundamental difference between like C sharp and Java. Okay, C sharp, all your primitive data types are actually objects. They're actually objects. This value has methods. It has methods available to it because it's an object. Java's not that way. Like if you have an int in Java, that integer has no methods associated with it. Java's older, and C sharp in a lot of ways was based on Java, right? It's like C++ and Java had a kid, that is C sharp. Okay, so that's the first thing you have to understand. Our primitive data types can be, allows the better way of saying it is that all of our types inherit from object. So it's a child of object. Because of that, because of inheritance, you can upcast your variables. Your integers can be converted into objects. And that is the whole process is referred to as boxing. And so here we've got an integer called value, right? Very simply. Notice here I've got an object. This is the data type object. The variable identifier is boxed, equal to this integer called value. So you've got on the left-hand side, you've got an object data type. On the right-hand side, you've got an integer data type. That's called upcasting. You're converting the integer into an object. And that is a valid line of code. That line of code will compile because an integer is an object because of inheritance. And you can upcast from child up into the parent. So what happens here is you take that stack variable and you put it onto the heap. So each boxing operation is a heap allocation. So you're taking a stack variable and putting it onto the heap. And it's the same thing the other way around. If you were to take this boxed object and put it into an int, that's a process called unboxing. So boxing and unboxing is this idea of casting between your data types. And what happens when you box and you unbox your variables is that you can see in performance critical loops or with large collections, this cost adds up quickly. And here it kind of shows some graphs about if you have an integer that even for a single integer, just like this last slide, if you have to box it, it says with boxing and without unboxing, but without unboxing is much faster. So the point is moving it between the stack and the heap, not the most efficient. So let's see. Let me see if I can read this slide just a little bit more. It says without unboxing, 1/100th of a nanosecond. And then if you have to box up your integer, it takes 3.5 nanoseconds. So if you box it, it takes 3.5. If you unbox it, it takes 4 nanoseconds. And why is that a problem? So the process is what you're doing is you're taking a primitive data type and converting it to an object data type. And that's a process known as boxing. And going the other way, taking an object, is a process of unboxing. And converting between those types slows your application down. Now you can imagine if you have a loop of 1,000 items and you have to iterate over that loop 1,000 times, 3.5 nanoseconds doesn't seem like a lot. But if you're iterating over a loop 1,000 times, it becomes a lot of time. Does that make sense? Why? This is a story that's going somewhere. Okay? This boxing story is going somewhere. There's also, if you have to do this in collections, you guys didn't even learn array lists. Okay, the short version here is that a list is much more efficient than an array list. So all that is on the right hand side. I'm not even going to introduce array lists because that's just old. We just use lists as our generic types. A list of T. Therefore, if you have a simple piece of data that you want to store and not have that problem of going from the stack to the heap and the heap back to the stack, you can use a struct instead. Okay, instead of using a class goes on the heap, you can use a struct. A struct is a class. A struct is a class that avoids the heap. So in C# we have classes and objects. A struct is a class that doesn't go on the heap. It only goes on the stack. Okay, so therefore you don't have to convert. You don't have to box and unbox, as we talked about being slow. Okay, now there's different kinds of structs, but notice the only thing here that looks different about this class, it's not a class, it's the keyword struct. There's different kinds of structs, and in this case, this is the most modern style of struct. Is called a ref struct. I'm going to talk about a ref struct here in a little bit. Let me just write a little bit of code and I'll show you basically what a struct looks like. So I'm going to create a new project. I'm going to create a console app. And I'm going to put this in my chapter 1 and I'll call this lecture demo code. And I'm just going to call this my product system. So the solution, the project, okay, I've got a console app. .NET 10 is the latest version of .NET. So you're going to need .NET 10 to get all these C# 14, right? C# 14 was released in .NET 10. So versions of C# are released. Okay, let's just dock this wherever you're supposed to go. Let's bring this over. Copilot, let's just dock you over here somewhere. Get you out of my face. Okay, so I just want to show what a struct looks like. along with what a record looks like. And I haven't talked about records yet, but I'll start with records. So here, notice I'm just going to add a class. And this is going to be a class called product. Okay, so keyword class internal. So I'm going to change the access modifier to public. I'm going to change the class to be a record. Okay, now records, even though I was just talking about structs, I'm going to come back to structs. Okay, allow me to kind of jump around a little bit. A record allows me to do two things. A record will test for value-based equality and is immutable by default. What does it mean to be immutable?
You can't change
Can't change it. Yeah, thank you. You can't change its values. So records are also a new, I'm talking about data types. This is a new data type. It is a class, okay, but it is a class that will test for value-based equality. I'm going to show you what I mean. Check this out.
How new are they? They weren't added in 14, right?
I do not recall when they were added. But they're new to me, so I'm pretty recent.
I've used one or two before that.
So records are good for transferring data from one place to another. And they're good for that because the data is immutable. It can't be changed in between. So a lot of times, when we're going to get into this MVC book, you can use records for what's called your DTOs. DTOs are data transfer objects. You're transferring data from the back end to the front end, and you want to make sure that nothing's tampered with in between. So records are good for transferring data because of their immutability. Now, this right here kind of looks like a constructor, doesn't it? Kind of looks like a constructor. A constructor is how you assign values to your fields. Okay, but this constructor is also newer syntax, and it's called the primary constructor. So this is and that's a C#9 feature. Primary constructor introduced in, okay, there you go, C#9. I'll assume that's right. Okay, so we have a record. It's called product, and it's immutable by default. So just to test that, now why is this not working? Probably because we need a using namespace. So I'm in a namespace here, product system. I think if I actually get rid of that namespace, now it's a recognized type. And it needs a string and a decimal. So we got a string and a decimal. Okay, it's compiling now. Okay, so let's do product P2. Okay, so now I've got two products, but notice the data is the same. Let me zoom in. Okay, so I'll say if P1 double equals P2, products are equal, otherwise products are not equal. We run this. It says products are equal based on their values. And you say, well, I would expect that to happen, right? Not in traditional classes. Let's make product a class. All I'm going to do is change a record to class, right? Change record to class and run that. And that should come back products are not equal. So benefit of records, number one, is that it will actually look at the values on, where is it looking? It's looking at the values in the heap. Classes don't look at the values in the heap. Classes look at the identifiers. They literally see, is P1 the same identifier as P2? Those are different identifiers. Those identifiers are still on the stack. The data's in the heap, but the identifiers are still on the stack. So this is actually literally just testing if those are the same variables on the stack. Okay, so let's change this back to record. So that's cool. This is a newer thing. C# 9, whenever that came out. What else is good? Is records good for? Well, here, if I make this a regular old record, so I can add some members, and I'm gonna make let's see. So typically, field. So let me say, I don't know if I have to do prop int. I'm just going to make the ID, and it's not going to be happy there. Record product ID must be a readable instance of the field. Oh, it's a string. Okay. So now I have a way to modify the ID, even though it's a record. You shouldn't be able to modify it, but I kind of try to make that a way to modify it. And if I come down here and I say p1.id equals, I don't know if that's going to crash on me. Let me just do products are not equal, console right line. Let me just spit out the product one ID. So we know that they're, in this case, let's see, these are back to records. Since they're records, they should be equal. Let me save and rerun that.
So you changed the ID in one of those.
I did change the ID.
They're no longer equal.
Yeah, it's supposed to be immutable though, because it's a record. It's supposed to be immutable. So I'm missing something there. Why is that allowing me to change that? Probably because I probably have a conflict here the way I did this. Parameter ID is unread. Let me see if it made the, let me go back to just what I had here. Put the semicolon right here. I might not be able to use this primary constructor the way I want to, but here, let's try this again. Now we're getting build errors. That's what I would expect. Okay, so it's immutable. You can't do this. Okay. Back to a struct. Now in my demo, I made an interface, and I'll explain why I did this. But let me add a new item. I'm going to add an interface. And this particular interface I called iLogger. And iLogger has one method which inputs, takes in a message, and we're going to probably just put that message into the console. Has no return data type, right? So remember, interfaces in C#, interfaces are just a list of empty methods or abstract methods. In this case, this is one empty method. It has no method body called log. And now I'm going to create my struct that implements this iLogger interface. Okay, so I'm going to make a new class. So I'm going to add a class, but this is going to be called stack logger. Okay, I'm replacing the word class with ref struct. I'm going to make this public. Ref struct stack logger implements iLogger. So that iLogger interface, we need to implement the interface, which will bring in this log method. And this log method will do a console write line. Which will essentially say stack logger and then print out the message. Well, okay, I'm finally back to structs. What's the benefit here? Instead of having a class that goes on the heap, anytime I create an instance of stack logger, anytime I create an instance of this struct, it's on the stack. It's not on the heap. We understand that there's potential performance gains using structs over classes. Now, again, this is just a normal struct, but this is the ref struct that actually comes with some benefits. So I'm going to highlight those benefits here as I go. Here, I'm just going to touch on this left side very briefly. This is actually kind of interesting. Notice these data types called native integer and native unsigned integer. Native, you can kind of read through here, but it actually looks at your processor and determines whether your processor is 32 or 64 bit, and it will better align your data types with 32 bits or 64, essentially better for your processor, more aligned for your processor. And if you remember the difference between unsigned integers and signed integers, unsigned integers are only positive numbers. Signed integers can be both positive and negative. So if you have a native int, then that can go positive and negative numbers, whereas negative unsigned int can only be positive. Okay, I don't think you guys are going to be using that in this class. I just wanted to throw that out there on this slide. We can kind of skip that one. Okay, so we kind of talk about structs and how structs are there for performance, but when we get into polymorphism, right, we start talking about when we have parent classes and we have interfaces and we need to convert between all the different types. If you kind of walk through the history of structs, structs really couldn't, and again, structs operated on the stack, so they had performance benefits, but they couldn't interact with the rest of your applications that were classes and objects, and they had polymorphic behavior. And so classes and objects and abstract classes and interfaces, all those things that are object-oriented fundamentals, they enable this polymorphic behavior. And there's benefits to that in object-oriented programming. But then you have these structs over here that really couldn't do that. Okay, that's where the ref struct, a ref struct can implement an interface. So again, if you kind of go through just a regular old struct could not implement an interface. But this newest ref struct can implement an interface. And because ref_struct can implement an interface, it can exhibit polymorphic behavior and kind of work with all of your other classes, abstract classes and interfaces. And so the reason why I wrote this code this way is that this ref_struct, again, older structs could not implement interfaces. But these ref_structs can. So they exist on the stack and they can implement interfaces. So that's cool. Okay. Okay, we're on slide 11 of 14, so we're almost done here. A couple more newer features, if you will. Again, this builds on top of the first video, so hopefully you guys kind of finished the first video. In a typical class, you've got instance fields, right? Instance fields are also called the backing field. They're called the backing field because they exist behind the property. Notice the syntax here is traditionally underscore and then your identifier. The property is Pascal case, right? Capital letter, right? And then every new word is a capital letter. And so this property interacts with the backing field underscore name. So in order to set the name, you use the name property. In order to retrieve the name, you use the name property, right? But this is a traditional syntax, and this was shortened, right, with auto-implemented property. Auto-implemented properties are even shorter, right? So if I just make a class here, I'll just add a class called student, and I go into here and I use the prop keyword. I hit tab, int student ID. This is an auto-implemented property. Okay. The reason why these auto-implemented properties are not universally used, because what is shorter? Something like this or something like here on the left? Of course, auto-implemented properties are shorter. They do the same thing. Student ID will create a backing field called underscore student ID. But as soon as you need simple logic like data validation or notification, you have to abandon auto-implemented properties and write the manual backing field. So as soon as I need to say, hey, if the student ID already exists in the database, then don't insert the new student ID. So if you need some validation logic, which you typically do, then you can't use these auto-implemented properties. You have to go back to the longer syntax, which you would say that's more verbose, right? It just requires more code to achieve the same task. Well, C#14 introduces this field keyword. The field keyword kind of creates the backing field automatically for you. It literally saves one line of code. But now instead of using the actual backing property, you just use the keyword field, and it creates the backing property for you. So whatever, it saves one line of code. It saves you from having to create the backing field. The problem is there's a whole hierarchy of things you have to understand to fully understand what's going on here. But no manual backing field needed. So that's cool. You may or may not remember this concept called extension methods. If you make a class in C#, or let's just say Microsoft makes a class, there's the number class or the integer class. You can actually add methods to the classes that already exist. Okay, this right here, if you notice what's happening. So extension methods are ways to add in new methods to classes that already exist. I believe you guys covered extension methods in the first year, although that's been a while, so you might not remember them. But we did talk about them at least, I believe. Okay, but extension methods are a thing, and they've existed. Now there's a newer syntax for extension methods. They're called extension blocks. If you want to add a bunch of methods or maybe even properties to a class or to an interface, that's what we're doing here. In this case, these two, this is a property that's extending, and this is an overloaded operator. Okay, overloaded operators are like the plus symbol and minus symbol. You know, those are referred to as overloaded. These are both being added to the IEnumerable interface. So the IEnumerable interface is something that Microsoft gives us. Okay, all of our lists implement IEnumerable, so you can iterate over them. But now this is a property because this is a list. In this case, now we're testing if the list is empty. So notice we are actually, this is a new array, if you will. And so we're essentially adding, if you look here, this is a new array. We're adding this is empty property into our integer arrays. That doesn't exist by default, but we can add these to either things that we've coded, other classes that we've coded, or not. So this is called an extension block. Extension blocks, again, are something that's new in C#. And I think I did have a little coding example of extension blocks. Let me see if I have an example of an extension block. I think I do. Yes, I do. So notice here I've got a record called product. Okay, and remember, records are classes, right? So I'm going to, even though I wrote this, if I wanted to, add new properties to product, I have direct access to it. I could do that. But just as another way of showing you how these extensions work, I'm going to make a new class, add a class. This is going to be called product extensions. Now this extension block has to be in a public static class. The way this is done is with extension. We are extending, what are we extending here? Product P. So the class that we're extending goes inside these parentheses. We're extending our product. And I'm going to add a property here called isPremium. And if the product price is over 1,000, then this is going to return true. This is return true if product.price is greater than $1,000. So it's a premium product if it's over $1,000. And I'm going to add a method here that'll give me a discounted price. You input the percent, so you send in the percent that you're going to discount it. And if it's 10%, 1 minus 10 is 0.9. The product price times 0.9 is a 10% discount. This will return the product's price at a 10% discount. So these are referred to as extension blocks. These are newer in C#. That's how you code them. Okay, let's go back to this code a little bit more, and I'll flush out this example. So at this point, I'm going to kind of reset my source code, right? My program CS is empty. I have a interface called iLogger. I'm going to make a new class called inventory item. This is a public class inventory item. And I'm going to demonstrate the field keyword. In a property, not auto-implemented property. So here comes, this is my property. The property is called note. The get returns the field, and the set sets the field equal to the value. So there's no backing field needed here. And that's what's new. I've got product extension. So product is a record. Product extension simply extends product. And I've got my stack logger, and I'm not really using student. So I'm just going to delete student. Okay, now back to program CS. Okay. I don't know if I need that using statement. I'm gonna go ahead and make a product. So again, a product is a record. This is a newer syntax, by the way. You guys are used to this, right? Product, my product equals new product. Well, if you do this, this is gonna tell you, hey, you can simplify this down to just using the new keyword, right? So it will automatically infer the matching data type. So it's like, hey, we got a product on the left, so we need a product on the right. We need a new product on the right. So the type is automatically inferred. I'm going to make an inventory item. This is a newer syntax. Notice the question mark. Here, this question mark, this is called the null conditional assignment. This is null conditional assignment. So the way this works is if item let's see, so what did I write here? This is new, so I'm tripping over it a little bit. So I wrote this note. I said the null conditional assignment avoids verbose null checks. So you don't have to check to see if this is null before doing an assignment. Normally, you want to make sure that your reference objects are not equal to null. If they are equal to null and you try and put something in them, that is a exception. It will crash your program. Okay, so the way this works is that it will not do the assignment if item happened to be null and it were to crash your program. And it says it avoids verbose null checks. You don't have to see if inventory item is null before you assign it a value. Okay, so that's, again, syntactic sugar. is what they call that. Now that we have an item, we can set the note. Again, if the item is null, then we don't apply the note. This is a high value item. So this assignment happens only if item is not null. Assignment only if it's not null. So again, very common error is you got a null object and you try and put something in and it doesn't work. Okay. So now I'm going to use the extension methods. I'll say if my product is premium, remember the price tag's over $1,000, it's considered premium. If it's a premium, then I said the sales price and I basically say 10%, right? So give it a 10% discount if it's premium. So this is the premium, this is the extension property, this is the extension method. I am now using my extension property, an extension method, and then I output the status. The status says it's on sale. Oh, I didn't declare status. So I got to declare status. I'm going to declare status up top. Notice here, status is a string. Since strings are reference types, you can set them equal to default instead of null. And so default and null is kind of the same thing. So equivalent to null. So now I've got a string status. I say it's on sale. And this is sale price, not sales price. There we go. Last but not least, okay, I'm writing this method. It's a static method that takes in the type that you pass in. So it'll take in an argument. In this case, it'll be a stack logger along with the message. And here, I'm going to call this method process log a new stack logger and pass in the item.note. So it takes in a generic T. So the generic type, in this case, we're passing in a stack logger along with a message, and it's simply going to output the log. And okay, so there's a lot of new stuff here. If I run this, we kind of see this is the sale price of our product. And then the stack logger outputs our note. And again, this is nice because this is using the stack logger is a struct, which a struct is on the stack instead of being a class. So kind of more efficient. And Quinn asked a good question. It's like, well, hey, if structs are more efficient than classes, why don't we just always use structs? And the answer is structs still, even though we can implement interfaces, we cannot have inheritance. So you can't have child parent-child relationships with structs. So they're still considered like simple objects. More complex objects that have inheritance and inheritance chains, you still need classes. So you don't use structs in 100% of the cases. Okay, now with that being the case, okay, so when you guys are ready, I've added, very similar, I've added a programming challenge for your lab, which is number 10, where you're going to create a student record. You're going to use the field keyword. You're going to use an extension block. You're going to create a ref struct. We're going to check out that null conditional assignment. Okay, so all those topics that I just covered, you'll demonstrate in this small programming challenge. Okay, so when you're ready for Project 10, again, I think you're going to need to reference kind of this theory for that. Okay? But we should have covered what you need for that. So I'm going to stop this recording here.